All right, so um,
Oh God bless.
Does anyone have a pencil I can borrow? I will give it back to you.
He should come here.
all right, so what we're gonna do is we actually gonna give you like a idiot proof way to do it. I know some people can be visual, like Cameron and Alex, and Aiden. You guys are more visual type. You can see things much easier. But today's rotation, even for you guys, is gonna be a little bit harder. So it's called off-axis rotation. Yes.
Is there anyone that has a pencil here? I will give it back.
Anybody can let Stefano borrow a pencil.
Apparently I forgot mine. Thank you. Remind me to give it back.
Okay, so I'm gonna start with a kind of like a idiot-proof way to do something. So here's it's what we're gonna start. Is the first step I would say is draw the diagram with axis rotation. Mark the axis rotation part. Mark. Second, draw the line or lines from axis rotation to the curve. So if it's a one line, then usually means disk. If it's two lines, it means washer. Okay, if it's one line means disk and two lines means washer. Is that okay? Am I going too fast? Okay. 3. Which color was it before? 3. Now I'm gonna and after you draw a line, you're gonna decide dx or dy. If it's a straight line, a vertical line, that's a vertical line is usually dx. So vertical. And if it's horizontal, is dy. Now, once you decide dx or dy, you need to convert the function in terms of dx or dy. So if you got dx, convert the function into x term. If it's dy, you can convert the function into y term. Okay, so let's say if I have, for example, if I, like says dx term will be like y equal to x squared, and this one will be x equal to y squared, square root y. So x equal to square root y, so in term of y, or this in term of x. So that is going to be the distance. 4. Y term convert to y term or x term. Okay. Okay, so now I'm gonna says if it's a disk, then you're gonna use the following formula: a to b of r square of x dx, and pi, or pi between c to d r square of y dy. So if it's a washer, then you're gonna use pi a to b of r square of x minus r square of x dx. And it's gonna be from c to d, it's gonna be r square of y minus r square of y dy. So that is gonna be a disk. 5. I want you to also decide the boundary. Is the x bound or y bound? Okay, decide the boundary. So boom, let's say it's 1 to 3, or yesterday was homework questions 1 to 3 or whatever, or 0 to 3. This makes difference. Okay. Now we have to decide which equation to use, boundary, what's big R, what is small r. Now one of the biggest thing I want you to understand is if you have says function in terms of x, with f of x is equal to distance from x-axis to the function, to x-axis to the functions. If you have in terms of y, then it's going to be distance from y-axis to the functions. Seven. Don't forget certain things. I would say don't forget certain thing is don't forget the biggest thing is pi. Don't forget pi, because if you forget pi, it's wrong. So if you forget to put a pi in the front, it's wrong. The boundaries. The boundaries and the parentheses. I see people make mistake is they forgot to put a parenthesis. The squares. Okay, they forgot to put squares. And then dx or dy. So all those things you should check before you submit the answers, or before you move on to the next question. Make sure you have parentheses, squares, whatever need to be a square, whatever need to be a square, right? Is that okay? Now I'm going to start with the question. This is a question I just made up. So y is equal to square root x minus 2. Y equal to 0, x equal to 6. Okay, I want you to try to graph this function. First part is I want you to rotate around x-axis. So I'm going to start by draw the axis. Does anybody know how to draw square root x minus 2?
You move it, go to the right,
Aiden?
start from 0, move right 2, so it's -2, and then you
Oh.
go
I thought the minus
like a half parallel.
Yeah. That's okay. It's going to draw like this, right? Does that make sense? And there is stop right here at x equal to 6. And there's x-axis. Is that okay? Now I'm going to draw the axis rotation mark. This is the axis rotation mark. Don't forget the axis rotation mark. Oh, I skipped a step. Did I draw a step? Oh, no. Right there. Okay, so I draw the axis rotation mark. So within the boundary, I'm gonna draw a from axis rotation. So it's not this way. This way is wrong. So it has to be the other way. So it has to be the other way. It has to be the other way. How do I erase? There we go. Okay, had to draw from axis rotation to the functions, right? So had to draw from here. I'm gonna change color too. Oh, okay, no. Oh. How do I change the color? Oh, it is. So it's gonna be here. It has to be from axis rotation to there. Okay? So is it dx or dy? It's a vertical line, so it's dx, right? So you're gonna write down says dx. So for me, after this question, I'll figure out this is dx. From which bound to which bound? 2 to 6. Good. This is a disc or washer? Disc. Right? This is all fairly easy, right? Then you say, okay, well, disc has a big R. What is a big R here? Square root x minus 2. Does that make sense for everybody? So that's going to be integration. Don't forget pi. 2 to 6 and square root x minus 2. And don't forget parenthesis. Don't forget square. Don't forget dx. And that's it. You don't need to solve. Use the calculator to solve. So all your homework, I want you to use calculator to solve because I don't have time to teach you how to solve stuff. Is this okay? Now this is easy. How about rotate around y-axis?
That's gonna be from the same one.
Yeah, same one. Rotate around y-axis. So same one. Rotating around y-axis. So same thing, rotating around y-axis. See if you guys want to give it a shot. Okay. So if I'm rotating around y-axis, I must draw this notation mark to help me because that helped me later. I'm gonna draw from axis rotation to the function. So here is one line. Do you see that as one line? And do you see that there is another line that's going from here to here? And do you see that's a longer line there? Is that okay? So do you see that there's a longer line? Then let me ask people. Brian, what do you think? Is it dx or dy? dy is that okay? dy? because small slice of y. Okay. It's a disco washer, Willie.
Should be washer, right? It's 2 lines.
Yeah, washer. So there's a washer here. And from what bound to what bound? Stefano?
From 0 to 2.
From 0 to 2. Good. So I will list down all the stuff. Now all we gotta do is, you know, it's washer. You got a R, big R, and a small r, right? But since you are in term of y, so that means y equal to square root x minus 2. So you have to solve for x. Yes.
Why did you put those 2 lines there?
I just told you draw from the axis rotation. That's one of the steps to kind of help you. Draw from the axis rotation to the end of the functions. And there's 2 lines because you had 2 boundaries. Within the first one is going to go from here to here, and the second one is going to go all the way to the second bound. So that's the inner radius and outer radius. If you think about this rotation, it's going to look like donuts, but it's going to be an edge on the side. It's not.
Is that red line supposed to be like 2 or is it supposed to be like?
What do you mean? Which red line?
Like the longer one.
The longer one is supposed to start here and go all the way to here, because you go to the second boundary. Okay? So we had to convert it. How do we convert it? Y squared equal to x minus 2, right? X equal to y squared plus 2. Is that okay? So this one is the distance from the functions. So R, that's a big R here. Big R is always equal to what?
The higher one.
Yeah, it's what? Yeah, what is it?
6.
It's 6. I read it.
It's the radius of the entire thing.
Mr. Gay, I said 6.
You have to divide the entire circle by
I think it's like, why would
It is. That's
It's from
Oh, wait, yeah.
it's from this point all the way to this point. Ooh, that's cool.
Oh, we're looking at. Mr. Gay, I say 6 and then you give me the dirtiest look I've seen.
I want to trick everybody. Okay, so 6, is that okay? But what is this?
Oh, it's 2 minus.
That's a function. What is a function?
Y squared
2 minus.
Well, because aren't they in terms of what?
It's equal to y squared plus 2. Is that okay? So that will be integration from 0 to 2. Don't forget pi. 6 parentheses square. Don't forget about square. Minus y squared plus 2 parentheses square dy. Does that make sense? You guys know how to do it now? Yes?
Mr. Gay, even though I wasn't here, still not here. Aren't you trying?
I'm actually, yes.
I wasn't here. I watched the video and I still don't know how to do it. Oh, there you go. Oh, I'll take care of it.
Where's Max go?
Wait,
Yes.
why do you, for the little r, why do you use the y3 plus 2?
Because that's the function. Anytime you have a function, look at the thing says the functions is from y-axis to the thing. So you think about it, like just assume that y is equal to 1, which is here y equal to 1. 1 squared plus 2 is 3. So here to here is 3 units. But if I plug in 2, then it'll be 2 squared plus 2 will be 6. It'll be all the way to the 6. That means your small radius becomes 6. But that's because there was no more to cut. Yes.
So when you're doing the length of the little r, does it have to be in the middle of the function?
Yeah, it has to be between 0 to 2. Is that okay? Now let's give you some harder one. Rotating around. Yeah, the same thing, rotating around X equal to 6. This one's kind of hard.
Same function.
Oh wait, I don't.
Yeah,
Same function. It's not gonna be the same thing. Now we want to rotate around X equal to 6 this time. Draw it out. This is the axis of rotation. So it's, what is it? What's the boundaries? What is the dx or dy? Is that disc a washer? Give me a second. I'll call you, don't worry.
No, I'm gonna have it rotating around the Y.
I'm not rotating around y. I'm rotating at x equal to 6.
Like this way or like this way?
At x equal to 6. At this way here.
Oh, so all around.
So first of all, think about what kind of shape is this?
Like a bowl of baked bread. It's like a shell.
Yeah.
It's not a semicircle.
It's like a rectangle with like a little bit of curve taken out of it.
Like a dumpling.
What dumplings are
Is
we
it just
looking
like,
at?
is it like half of a
Chinese
That's a
dumpling?
really flat dumpling.
What?
That's a weird looking. That's a weird looking dumpling.
It's like a hamburger bun.
Yeah, that's what I said. What?
Or like a frisbee.
Yeah, this is how it's.
Like half bottom, half
It's a hamburger bun.
I'm confused. That's why it's going.
Huh?
Wrong shape.
Yeah, you put it like this. Oh, dumpling.
It's like you had both at like a quarter of a circle.
It's a dome. No, Alex is right.
It's a dome.
It's a dome. I like that.
A dome is not a semicircle. Those are vastly different shapes. Like not even close.
I still go with
It's like a hamburger bun, I would say.
Like it's a dumpling, like some dumplings.
All right. Shh.
Actually,
Shh. All right. So. Shh. All right. Whatever shape is, I mean, you guys go argue whatever, but I would say let's do the calculation. Let's try to use this idiot-proof way. Is this a disc or washer, Samantha? It is disc because you draw from here and you draw from here to here. That's one line. Then you're gonna say all the way to the second line is a y-axis but y-axis is not part of the graph. Right? A lot of people thought it's all the way to the y-axis. No, it's only one line. So, Willie, is that dx or dy? dy. Okay, what's the boundary, Willie? No. No. It's actually 0 to 2.
Oh, why? Wait, why?
Because your rotation is right here, right? And you stop at y equal to 2. Okay. Now, is this a washer or we already talked about this a disc, right?
Yeah.
The problem is this disc is kind of hard. Okay, so there's obviously there is a pi and between 0 to 2. So what is the radius here? Which is what is the green line here?
Is it not 4 minus y squared? Oh. Is it y squared minus 4?
So we're going.
Y squared.
Oh wait.
We're going from the in.
Wait, you have to check it,
right?
Y squared.
I'm sure it's not yes, and it's just the same.
I feel like
What is it, Cameron?
1 squared plus 2 and then squared. What are you looking at? What?
You know how like Queen's Gambit?
You kind of like indicate something to me.
God, please pray for this guy. No. Anybody want to like to try?
Well,
Is it not y squared plus 3?
if we do it the way the integration stuff we did before, it would not be 8 minus
8?
Yeah, because that's the rectangle, right? But it's not.
Or do we plug in?
What do you mean?
Okay, hold on, hold on. It's not a washer, that's
Wait,
not
where do you
8,
get-
that's 6.
No, because we're gonna
Kim?
say
1, 2, 1, 2, 3,
Yeah, 8 from.
Huh?
'cause it's 4 times 2.
No, but it just
Is
be
it,
the
are we multiplying
It
root
just
of
be
x
the
plus 2?
function is square root of
All right. So pay attention what we say earlier, right? We say the function is from y-axis to the curve because this is in term y, right? Remember, we have to do dy. dy is y equal to square root x minus 2. That is a distance from here to here. However, that you had to figure out what is this. You had to figure out says, okay, that's a y. We're gonna figure out is it's y squared equal to x minus 2. So x equal to y squared plus 2. Is that okay?
Sure.
But y squared plus 2 is right here. This one is the x equal to y squared plus 2. Why? Because you think about if I plug in 1, that's going to give you 3. Exactly 3 units right there, right? So what is my green line, which is the green line is something I'm paying attention to, is this line from here to here. But what is that line? No. Is this subtract that? Is the whole thing subtract the red to get the highlighted part? Because the whole thing is a 6, right? So the r here is gonna be the r of y is equal to 6 minus parenthesis y squared plus 2. Why? Because it has to take a 6 minus the red to get the highlight part. So it's gonna be 6 minus y squared plus 2. This is the r. Now we have to put another parenthesis here, square. Don't forget another parenthesis, and the dy. Do you see that? It's kind of hard to see because you gotta understand. But this is rotation to the curve is different than function to axis. You have to take a whole thing, subtract that. Does that make sense or no?
Yes.
Okay, who says no? Raise your hand. Okay, yes, Sydney. Go ahead. So remember, we are focusing from here to here. So I'm gonna maybe use I'm gonna use this line here. I'm focusing from here to here. This is what I'm focusing on, right? So this is focusing on this blue line right there. But the red line is the function. So I can take the green line minus a function to get a blue line. Are you following me? Are you guys following me? Are you sure? Okay. If you're sure, then we're gonna give you some harder one.
Oh,
Oh my gosh. When I said I was sure,
So rotating around y equal to negative 4.
oh, same graph.
Yeah, same graph. I can give you all different kind of rotation.
Are you teaching Thursday?
What?
Are you teaching something?
I'm taking the day off.
Yeah.
I don't want to.
Are you doing it again?
I'm not gonna be here.
Oh, I'm not showing up to school. Are you doing something Wednesday?
Mr. I would only come to your class, but now I know you're not.
You're leading by example for this generation.
I wanted to go, I might be late tomorrow, but I don't know yet.
Okay.
Killer. I just beat her ass.
Put her pin down. 0.
You're for the gray.
Put her on one.
Put her on.
Yeah, you already put me on one probably. You put me at 0.
No, you had 2.
You're gonna get her paid.
You had 2. You're not 1. You have 2.
Negative?
I'm at a 2.
Yeah, the people on 1 it will be Chris, Max.
Max?
Yeah, Max at 1.
Hell yeah.
Max, you're at a 1?
You haven't show up.
Yeah.
What's Josie at?
Max, go show up. Am I at least at a 3?
Say it.
Just don't.
Say it.
Huh?
Just keep
What's
it-
Josie at?
Keep it a secret.
Josie?
What's Brian at?
No, she's not being used her iPad. I cannot.
Oh, so she's like,
I cannot be mean to her.
Cameron?
Yeah,
Yeah, what
can't
am
do
I?
it with that.
Cameron? Cameron is like 2.2.
Okay, I don't get why you hate my homework so much.
What about me, Miss
Am I a
David?
Don't give him a 3.
Alex did not get a 3 if I have a 2.
I'm gonna turn you
I
through.
get the
He
3.
apologized on his test. One test.
Okay,
I'm going to pass this.
who can figure out this one?
I'm already working on
Nah,
this.
get a 5. They get a 5 when they get this. I'll tell you what to say.
Where's Amelia? Did you text her?
Put her down. She's getting a 0.
Who is this Amelia girl that you're talking about?
No, that's real.
Who's Amelia?
No idea what he said. What he said.
I'm very confused.
You stop. You stop counting. Hello, this guy, man. Wait, what? It's slow. Kid had a phobia.
But I'm teaching tomorrow.
I don't need it. History, I
And you might look, you're about to cry. Okay.
I feel like I'm about to cry.
Oh no, I don't know what the hell this is.
Go get there.
It's like the one unit that kind of makes a little sense.
Mr. Yeah, I was in the wilderness, the deep woods,
History, I don't listen to her.
while you're teaching me your rotations of dumplings.
First of all, are you hungry? Why you keep on thinking about
Oh,
dumplings?
yeah. Big water balls down.
You can answer how we have them work.
You already lost me with that.
Actually, I'm pretty much safe.
Maddie, why do you think you're gonna say? Like, yeah, like Maddie, even I did that.
Oh, I see. I'm using it. We're not moving, we're leaving it alone.
All right. Crap.
I have that line.
Yeah, give me a second. Let me redraw that.
Or take your time to do this. Okay, it's hard for all.
No, I do that.
Drawing is hard, this is why we teach how.
Why is it so big? You have to go to fit the numbers around it.
No.
The hands room.
Okay, so this is the axis rotation now. Do you guys draw this or no?
Yes.
Okay, do you know is this dx or dy?
Yeah.
Dx and is a washer or disk?
Washer.
What?
Washer.
Then it has the other side.
There's a wash.
Burn in a second. What?
So do you see that's a washer?
Yeah. So I did it. Right?
Because the red line is the hole you carve out.
Wait, but why is there 2?
Because you had 2 boundaries. There's one part of the boundary and a second part of the boundary. Okay?
What do you mean?
Why equals
This is
zero?
the boundary of the graph. This part is the boundary of the graph. This is the bottom bound. The other one is the top bound of the boundary. This is the graph that we are rotating. So you're gonna hit the first bound and hit the second bound. Is that okay? So is this dx or dy?
Yeah.
Dx. Okay, what's a boundary? Okay. We say it's a washer, right? Okay, so here's the thing. What is the small r here? What is small r here? It's always 4, right? Does that make sense?
Yeah.
what would be the I don't know which color is this. Which color is this? Blue? Okay. Blue, which, how about a blue line? The blue line is what?
4 plus parentheses square root x minus 2.
Yes, good job.
Three.
So, so the big R is equal to 4 because you draw 2 segments plus the function. And the small r is what? 4. So the integration between 2 to 6 pi, and then it's gonna be 4 plus square root x minus 2 parentheses square plus minus 4 square dx. Does that make sense? Samantha says, I don't know. Huh? You don't have to visualize it now. I'm just trying to show you that you don't have to visualize it. If you draw a line, remember this is axis rotations, right? You draw a line, the second line. The second line is gonna be the longer radius. So this is a longer radius. But longer radius is basically composed of 2 things. One is the distance from -4 to 0. The second one is from 0 to the function. But the 0 to the function is x minus 2, square root x minus 2. Oh, how do I know? So guys, the thing's gonna start here, and then gonna finish rotation at here. It's gonna be 2 to 6. That's it. Because our line is like this. Kind of, you think about areas. That's another way to think about it.
Wait, Mr. Ye, what'd you plug in for x?
Huh?
Like, how did you get 4 squared dx from that?
4 squared dx. 4 is the small radius from here to here. So this one here, parentheses here too. No, I didn't say let me go to jar. It's minus. It's a minus. Big R minus small r. Okay, you ready for the next one?
That's the street that. If it's in the middle of the graph.
Okay, so how about rotating? Let me give you a hard one. Around y is equal to 10.
Oh!
No. Oh yeah, y equal to 10. I mean, I make smaller. Let's say that says 6.
Oh, isn't that, we already did that?
No.
Oh, wait, my bad. Yeah, my bad.
What the hell is quiz, man?
That's sweet, bro.
Quiz was trying so hard last year. This year is last year is my class. He will stay here after school for like another 2 hours to finish the test. But this year he's like slacking. Yeah, he's in.
Is it or rotating around x minus 13?
Y equal to 6.
What are you talking about? That's then you do down, you do from the rotation. So yes.
Did you guys have this so far?
Yeah,
I just want to make sure drawing's correct.
6, then you lose it.
We're rotating on y equals 6.
I know, but like when you put in the equation.
What time we get off?
9:10.
Okay, so I'm gonna start here. This one is gonna be from here to here. This is the small r, and this is the big R. Is that okay? Yeah. Okay, so it's the dx or dy. Dx 2 to 6, and then what else? Washer. Okay, so what is the big R here? 6. That's it. 6. What is small r is a hard part?
The function minus x.
Is it 6 minus function?
6 minus a function.
Even
The function is what? So therefore, it's gonna be integration pi. Don't forget pi. 2 to 6, 6 squared minus 6 minus square root x minus 2 squared dx.
watch out on the
Do you?
I don't use
No, yeah, she didn't do homework.
I didn't
I did.
work.
I don't use it in my next classes.
Are you sure?
Yeah, so just tell Sam to take it.
Okay. Okay. Thank you so much.
If it closes, it's 1,437.
The same no? I'm probably gonna forget.
I'm still.
I'm gonna forget because I'm really bad. I reset my password like 1,000 times. So even you told me, I won't remember it. I don't even know my own password. That's how bad it is.
On and I understand what's going on. What did I do?
That's the worst.
Surprising.
I know. I thought that's a part of your struggle, but I did geometric stuff. You actually
No,
pretty
I'm
good.
good at geometry. I got 5 on it. It's the why don't you subtract the function?
Yo, she left without her
Why
iPad.
didn't you?
She let me go.
Why are you? Cause so you know how we.
Why did you subtract this?
Because this subtract this.
Well, aren't you taking the distance of this and not the inside?
So we are looking for this distance right here, right? So we take it the whole thing, which is the from here, subtract this part, which is this part is the square root x minus 2.
But why did you add it in the
Yeah,
last question?
That's what I'm saying. Why wouldn't you put this in front, minus it by 6?
Yeah, because you take the bigger one, subtract the small one to get this one here.
Why can't you do the other way?
You cannot do the other way because you don't have enough longer. You don't have long enough. What are you doing here?
Why are you here?
Why did you add it on this one though? Like why did you
Because
do
this one's
plus?
2 lines. Because this one is not subtracting off. This one's this distance plus this distance.
I got it. Thanks.
I won't be able to make it to this class tomorrow, because I have a testing with computer science. I